Collections is a Python module that contains several specialized data types that are alternatives to list, set, tuple and dictionaries. In this video, we not only cover these, but we also have a bonus section comparing approaches to counting words from a file. We also have a substantial challenge for you. We start off with collections with the counter. So from collections we're going to import counter and we're going to give a simple example here. Now you can count from a string or a list or a tuple. We're going to use a string here. So here's a string of just random letters and we want to count how many times these letters occur. So we can create the counter data structure from that string, and when we print it you can see how many times each letter occurs. So we run that and you can see each letter and how many times that occurs using a counter. Now we covered counter in detail in the last video if you want to see more details on how to use counter. Now let's move on to the next item that we're going to cover in collections. We're going to cover order dictionary and we're going to cover default dictionary. Here we've got a simple dictionary we've called X and we've added some letter values which are the values to the keys, which are numbers 4, 1, 3 and 2. So we can print that dictionary. Now you can see it's printed in an order. Now if you want to make sure it stays in an order you can use ordered dictionary. Ordered dictionary. So from collections we import ordered dictionary. Instead of having X as a normal dictionary, we create the ordered dictionary data type. So now once X is the ordered dictionary, we can guarantee that once those entries have been put into that ordered dictionary, then when we print it, it will print in the same order. Now this might seem that we haven't actually changed anything, but if you use a different version from 3.7 of Python, or in some systems that order is not kept with a dictionary. If you want to make sure the order is kept, you can use ordered dictionary. Now back to our normal dictionary, you can see if we print some values from that dictionary, like 1 equals the value A, 5, well there is no 5, so we get an error message. So what happens if we want to change it so we don't get an error message? Do we have any options? Yes we do. We have default dictionary. So now we want to import default dictionary from collections and change X from a normal dictionary to a default dictionary. So we change X, we create the data type default dictionary and we can give it a default value. Int, for example, has a default value of 0. So now when we print that index that doesn't exist, instead of giving us an error messages, it gives us the default 0. Now if we don't want 0, we can create our own little function. So here we create a little function called nv, and instead of printing 0, it's going to print no value if the key doesn't exist in that default dictionary. If it does, it will just print the value as you wished. We can print 1 and 3, which is A and C, but once we print something that's not there, we can see it prints no value. So we can look at our collections. Here we've got the module in Geeks for Geeks website, and you can see we've got the counter we've looked at, and also the order and default dictionary, which we've just covered. Now there are other data structures that we can cover as well: chainmap, namedtuple, deque, and we've got user dictionary, user list, user string. Here's an example using chainmap. We've got 3 dictionaries. We've got age 1, age 2 and age 3, and we've got the key the person's name, and the value is their age. So we import chainmap from collections, and then we're going to create this object, this data structure, using these 3 dictionaries. And then when we print that and run it, you can see that we've got the 3 dictionaries all together in the chain map. Now, a way we can have a look at all of these values together is we can use a for loop and look at all the items. So now, once we use the loop to look at the items and run that, we've got all of the keys and values together. So you can see all of the items. Now, what's interesting is if we add a value, a key and a value in one of the dictionaries that's the same, so we've got a key and value the same in 2 dictionaries, it's got to choose which one we want. And it overwrites, if you go from backwards to forwards, it overwrites. So in this case, we've got side 21 in age 1 and side 19 in age 3. So the first one will overwrite the second one. So when the values go in, it will look at the last value, then the second, then the first. It goes in backward order and overwrites. So let's have another example here. So we've got Al at 19. So if we change Alan to Al, you can see that we've got 19 and 19. So we just changed the first value to 20. And then you can see the 19 has been overridden by the value 20. So that's a quirk you might see using chainmap. Moving on, from collections we can import namedtuple. In this example we're going to name a named tuple called a date. Well, we've got day, month and year. So we create a date object, and that's a named tuple, and we can access each of those elements. So let's create a new date, which we've put as the 1st of April 2021. And you can see here we can print the month by saying new date.month. So we can access elements of this named tuple. So we can print it, you can see we've got April. So we could do the same with the year, new date.year, and also we don't have to use a name, we can use a place. So we can add new date 0 would be the day. So if we print them, we run that and print them, and you can see we'll have the month, the year and a day. So month equals April, year 2021 and day 01. When you look at user dictionary, we can see it's quite complicated. It's just used to add on extra functionality, the same with user list and user string. So we don't really need to cover these. Here we've got deque, which we're going to cover in detail in the next video. But here's an example. We start off with a list called nums, which has numbers 1 to 7, which we're going to put in a deque. Now, when we run this, that's going to print that list as a deque. Now, the reason why we use it is because we can access elements from both ends. So normally with a list, you can access the last element and remove it quite easily, but the first element not. So we can pop from the end, and we can pop left from the beginning of the list, which is crucial if you want to use a queue data structure. So here you can see we've got our deque, numbers 1 to 7. We can remove from the end, taking off the 7, and we can remove 1 from the start. So that's deque. Looks like deque, we use it for queues, but it's pronounced deque. Now, can you remember the beginning of the video? We said we have a special bonus section looking at the approaches to counting words from a file. There are several approaches you can take to count the amount of words, the amount of times each word occurs in a file. Now here we've created a file called anytext, which is a text file, and we open that file and we save the text inside it. Now the first approach we're going to take is counting all of those words, how many times they occur, by using the dictionary and the .get function. So we get each word and count them from the file. The second approach, we use counter. So we've seen this from collections. So we're going to time each approach. So the final, third approach, we're using default dictionary. So we create the default dictionary and then we count the amount of times the word occurs. Now we set a starter and a stop, so we time how long it takes each approach to take. So when we run that, we can see how long each approach takes. It's quite small, so we multiply it by 10,000 so we can see the figure more easy. Now the figures can be affected by the computer speed, so we need to run it a few times. So let's run this. We can see the times are quite close and they're in order. Fastest is the final approach, the slowest is the first approach. We run it again. Now the second approach is quite long, but each time we run it, the final approach using default dictionary is the fastest. So it's beaten using the dictionary with .get function and using the counter. So the default dictionary is the fastest approach using this method to measure the time it takes to run. So the default dictionary, because it doesn't look to see if the value already is in the dictionary, it has a default, means it's faster than the other two approaches. Your challenge is to print each letter of the alphabet and the amount of times that letter occurs in your name. If it does not occur in your name, you should have a default value of no printed. Added to the requirements is use the letter from a deque, from the front of a list or a front of a deque, and also when you create your first dictionary you want to keep the order. So you might want to use an ordered dictionary. And that's quite difficult to understand. If you can, great. See if you can meet that challenge. But if not, we've broken that down into 5 exercises. So here they are. So let's look at the exercises. Exercise 1. Create an ordered dictionary using your full name of letters and a 0 count for each letter. Now exercise 2. Create a default dictionary with the default no if the key is not in the dictionary. Exercise 3. Create a counter that counts the letters from your name. Exercise 4. Create a chain map from the 2 dictionaries in exercise 3 and put the values in a default dictionary from exercise 2. Exercise 5. Loop through your answer from exercise 4 using the first element of a list or a deque of the alphabet. So you want a list of letters from A to Z or a deque. We're going to take the first letter from that list and then print that letter and the amount of times it occurs in your name, or if it doesn't occur, it prints no. So that's exercise 1 to 5. Let's have a look at the solution. We start off with exercise 1, where we import collections and we're going to create this ordered dictionary. Now we've got our name as a string and we're going to loop through that and create this ordered dictionary using the letter, each letter from the string, and we're going to make the value with that key equal 0. And if we print that, you can see we've got our ordered dictionary with each letter with a value 0. Now in exercise 2, we just create this function that returns no, N-O, and we're going to create this default dictionary that calls this function, and if a value doesn't exist in a dictionary, then it's going to print no. If we print that, at the moment there's nothing in the default dictionary, so we just have default dictionary that's empty. Exercise 3 is quite simple. We just create our counter and we're going to count the letters in our name. So there's our counter. Now exercise 4, a bit more detail. We have a chain map and we're going to create the dictionary. We're going to create the change map with the dictionary that we've just created in exercise 3 before dictionary that we created in exercise 2. So we're going to create the default dictionary and the counter and put them into the dictionary data structure and add those together, put them together in the chain map. We use a for loop to put them together. So we're going to print that, and then you can see that we're going to put them into the default dictionary. So let's run that, and you can see we have our letters and the amount of times that they occur. So they will now go into the default dictionary, so we have the amount, or if the letter doesn't occur, then it will have the default no. Ready for exercise 5. Now in exercise 5 we're going to first of all create a string with all the letters of the alphabet A to Z, and then we're going to create this deque with these letters. So if you like, it's like a list with A to Z letters. So we can print that and you'll see that we have our deque. So there's a deque A to Z letters. Now in a loop we're going to go through each letter and we're going to print that letter, and we're going to print from the default dictionary from before the value. So it's either going to print the value as in the letter, how many times it occurs in the name, the string or the name, or it's going to print no if it doesn't exist. And we're taking it from the beginning of the deque, beginning of the list if you like, by using pop left. So when we run that, you can see we've got A occurs twice, B did not occur, C once, D 3 times, and we can go through the full alphabet that we've popped from the left of the deque and know if it doesn't occur or the amount of times it occurs. So that's the answer, the full solution to the challenge, and also exercise 5. So that was pretty involved. So if you managed to do that, well done. Well, that's great if you managed to do those exercises. Well done. And thank you for watching this video. Now if you've learned anything from this video, why not subscribe and learn more from our simple tutorials.